if I'm a developer and I want to make use of this, how do I do it? Well, we've got a brand new open source GitHub repository, the Aurora Contracts SDK. This is a QR code here that'll take you right to that repository. This includes a Rust library for your near contracts to be able to interact with Aurora. And it includes a Solidity library for your EVM contracts to interact with near. So this is covering both sides of that communication. And it also includes documentation and examples so that you can get to know this library, figure out how to use them, and integrate it into your own projects. So let's go ahead and take a look at some of those examples right now. So the first example we're going to look at is a Solidity example. This is a EVM contract that is deployed on Aurora, but it's going to call the social DB deployed on near. Now, social DB is the storage layer that backs the near.social decentralized social media platform, which is a super cool thing in its own right. But what we're going to do here is call it from Aurora, and that could enable, for example, a MetaMask-based entry point into the near.social network, and that could be super cool itself. So this is a high-level sketch of what the example is doing. Right? So we've got our EVM contract deployed on Aurora, and it's going to be calling the set function, which is on the social DB contract deployed on near. And we're going to include a callback back to the EVM so that we can get the result of that call. Now, the set method on social DB is exactly how you store data in the contract. So again, you could try to use this, for example, to try to build a MetaMask or other Ethereum wallet-based entry point into near social. So OK, so what does this code look like? Well, it looks just like normal Solidity code. You've got your contract definition. You're using an open Zeppelin library and access control, which tons of people will be familiar with here. And all you have to do is add in the Aurora SDK library for the near-related pieces that you want to use. So for example, this is the definition of that set function call. Right? So we have this nice near.call command or function method in the SDK. You can see it takes the account that we want to call, the method we want to call on it, what data we want, the near and gas that we need to attach to that call. And attaching near is important so that we can cover the storage that we're incurring in the social DB contract. But what's super cool about this is the cross-contract calls feature is making everything seamless in between these two sides. So inside the EVM, the attached near you're using is an ERC20 token. It is the wrapped near bridged ERC20 that comes in over the Rainbow Bridge into Aurora. But behind the scenes, the cross-contract call feature is going to bridge that token back, unwrap it, and turn it into the base near token so that by the time it hits social DB, you have just base near. So on both sides, you're using the preferred token type, ERC20 in the EVM and base near in social DB. And then, of course, we want this callback back into Aurora to do any error handling we might want to do on this call. So that's what the near.aurora call does. You pass in what address you want to call and any data you want to pass to it. Let's take a look at that callback. So this is what it looks like. Again, pretty simple method, right? Aurora SDK, promise result. This is getting back the result of the near call that we made and making sure it was successful. And if it wasn't, we can do some error handling. In this case, of course, I'm just doing a revert message, keeping it simple for the sake of the example. But you can imagine, depending on your use case, you might need more sophisticated error handling there. So let's move on to another example. This is going to be a Rust example. So this is a contract deployed on near, which is going to call the Uniswap contract, which is deployed on Aurora. Uniswap is an automated market maker. It's a really important piece of the DeFi infrastructure on Ethereum mainnet. And on Aurora, we've got a number of similar contracts deployed. Again, high-level sketch of what this looks like. So we have our near contract deployed on near. We've got Uniswap. It lives in the EVM. And the near contract is going to call, in this particular example, the exact output single function. So this is a sort of low-level API in the Uniswap contract, but basically it just means I want to perform a swap on one particular token pool, and I want a very specific number of tokens to come back from this swap. And once again, we're going to include a callback so that we can get the result of the EVM call back into our near contract to do any error handling or success handling as well that we might want to do. So again, what does this code look like? Well, we're still using the same tools. Just like before, we were using standard OpenZeppelin tools. Here, we're using the standard Near SDK with Near bindgen. Now, you do have to add some extra code that does come from the Aurora SDK library. So what we want to have is full integration with the Near ecosystem. Typically, JSON is used to pass in arguments. So up at the top, we're still taking in those arguments as JSON, but then we need to re-encode them into the Solidity ABI to be able to pass it into the EVM. So that's what that big block of code in the middle does. It's a lot of lines only because there's a lot of parameters that go into this exact output single function call, but it's not very, very complicated. And then at the bottom, we actually do the cross-contract call. So we are, again, following the same patterns coming out of Near SDK, right? We have the ext trait that is able to create this thing that does the promise and actually makes the call, and we can attach a callback to it. And if we take a look at that callback function, again, Near SDK patterns are followed. We're saying, OK, the engine gives back its result using Birch, so we'll define that as the serializer. And this is, in fact, a callback, but we can still write it in this really nice, still rusty style because of the magic of Near SDK. That submit result type that you see there is defined in the Rust library coming out of the Aurora contracts SDK. And you can see here it has a status field that'll tell you whether the result was successful or not. And then if it was, we can re-encode it into a lovely JSON output for our Near users. And if it wasn't successful, we can make an error message. And that's it. That's all I want to tell you for today. Again, the QR code is up on the screen. This will take you to that new open source Aurora Contracts SDK for you to use. And I encourage you to build something cool with it. Build a cross-ecosystem application that has both Near and Aurora pieces involved. Maybe even do it for the ETHDenver hackathon this weekend. Thank you all for your attention. If you have any questions about any of this, please come talk to me. I am super happy to talk about this all day long. So if you find me at the Near booth later in the day or just walking around, feel free to say hi. Thank you so much.